We're now going to look at the effect of changing the minute volume to change the end tidal CO2 by decreasing the minute volume, and we would expect to see a rise in the end tidal CO2 as removal from the animal is reduced. This could be, in a clinical situation, could be an animal breathing spontaneously, or it could be a ventilated animal that's not actually been ventilated enough. So with our situation as it stands at the moment, we have the animal ventilated 15 breaths a minute, an average tidal volume of 200 mils, giving us a minute volume just around 3 litres per minute. And as we see from the capnograph, we've got an end tidal value of 43 millimetres of mercury, which is where we'd like to be in a stable anaesthetised animal. And I'm now going to change the respiratory rate to reduce that minute volume from 3 litres down to approximately 2 litres per minute and see the effect. So we're around about 2 litres a minute. We've now dropped to 10 breaths per minute, and we would expect our end tidal CO2 value to start rising. So you can see it's now starting to creep up. We've gone up to 48 millimetres of mercury. Over 50 now. 56. And this is a typical response that you'll see over a few breaths in an animal when you change the minute volume for a ventilated patient. And we're going to settle around 56, 57 millimetres of mercury, which in a clinical situation would be considered too high, and the reasoning then would be that our minute volume is too low, which indeed it is, as we've just reduced it. Just to clarify that when we changed our ventilator setting, we changed the respiratory rate. Minute volume is composed of 2 components, the respiratory rate and tidal volume. There's much more flexibility in the respiratory rate to change the minute volume than there is in the tidal volume. Often you've set the tidal volume to be a particular value, or as in this case, we're pressure cycling to a certain pressure, where we have marginal control over the tidal volume, but we have much more control and flexibility over the respiratory rate. I'm just going to reduce the expiratory time now back to 3 seconds, bring our minute volume back to 3 litres, and we should see a return of the end tidal CO2 back to near where we started.